Thank you very much for giving me voice. Today, I'll be talking about ozonation as per treatment of digested swine manual prior to microalgae culture. The work is in cooperation of Professor Dr. Godos and Raul Munoz from Valladolid University. The work is studying how ozonation could help us to phosphorus and nitrogen recuperate, recycle, and making it another our fertilizer. This case is dilution on coagulation. The discharge of untreated livestock wastewater could potentially endanger ecosystem and human health. The continuous increase in meat demand has resulted in industrialized farming practices and our manual waste, present high concentrations of contaminants such as ammonium, nitrogen, phosphates, which cause eutrophication and pollution of groundwater. Anaerobic digestion is widely used for organic waste treatment with simultaneous burn energy and in the mitigation of greenhouse gas emission. However, this process only removes organic matter, while the concentration of nitrogen and phosphorus remain at high level after the digestion. The final effluent digested is more mineralized than pig slurry, and treatments aiming to reduce the nutrient load must be applied prior to discharge. Microalgae culture has been suggested as a secondary treatment after anaerobic processes of wastewater of different origins, as it can reduce the concentration of pollutants through nutrients assimilation and oxygenation. Remediation is a suitable, sustainable process that could replace overall expensive wastewater treatment or complement them thanks to the potential of microalgae to absorb carbon, nitrogen, and phosphorus, produce a valuable biomass composed of lipids, proteins, and carbohydrates. The growth in microalgae depends on various abiotic factors, such as light intensity photoperiod, nutrients, temperature, pH, or the presence of toxic compounds in the culture or medium. The light limitation of microalgae cells is often documented due to fulvic and human compounds and melatonin. To reduce the light attenuation, chemical and physical ozone phantom system calculation, strong dilution has also been referred as a conventional technique to increase the light penetration to reduce toxic effect organic compounds. However, the large consumption of blue water can jeopardize the sustainability and viability of a process. In a sense, the analysis of food water have revealed the instability of microalgae culture in several parts of the world. In this scenario, chemical pretreatment aiming to reduce dark color of digested has been proposed as one of the most attainable solutions. Through the dissociation process, macromolecular organic compounds are broken down thanks to the strong oxidative capacity of ozone. In this sense, the darkness of liquid is introduced since the structure of the chromophore group is destroyed by ozone. Consequently, after ozone treatment, digestate can be used as a culture medium for microalgae. Through ozone has been applied to digestate and other influence the efficiency in order to ensure the integration process. Previously reported experiences have shown increases in microalgae biomass generation where ozone is applied as nitrate and productivities of 20.7 gram in untreated nitrate and 19 gram per square meter in ozonated nitrate. In this case of dark tannery fluence, the microalgae biomass concentration increased from 0.65 of 0.86 gram per liter after ozone treatment. However, little attention has been given to the effect of the pretreatment on the net photosynthetic activity. This parameter provides a direct measurement of the light used by the culture, eliminates the possible bias due to the high impact of the experimental setup, where microalgae culture are assayed. In this sense, color is removed, increase the availability of light for microalgae growth. If the conditions of the culture system are not representative of the outdoor conditions, the yields and the rates can be overestimated. Determination of photosynthetic rates, efficiency simulated outdoor conditions, and biomass growth was modeled for better understanding of impact on kinetics. The digestate used as culture media for the microalgae was obtained from the anaerobic digestion of pig slurry of a farm located in Saquilo de Boniface, province of Soria. For the pretreatment of the digester, an ozonator was used for control the flow of ozone. A similar system was described by Meyer to calculate the actual ozone consumption in the column measurements of ozone concentration as both the inlet and outlet were taken using two real-time ozone analyses. This allowed determination of the amount of ozone consumed in the process. The ozone enters through the base of the column through a post-stone diffuser, thus generating microbubbles of this gas, increasing the contact between the ozone and the digested particles. The microalgae Akram was withdrawn from an experimental system treating urban wastewater, and the microbial population was mainly composed of Desdemonas and Pseudomonas vacuolatus. As light source, two light-emitting diodes controlled by two drivers, an Arduino microcontroller, were used to simulate the light cycle according to the model described by Gonzalo et al. The solar radiation was estimated as a function of its location and position following the model described. Today, the variation of the light intensity were converted into polynomial equations corresponding to the conditions simulated. In the order to obtain replicable results in the outdoors conditions, radiation and temperature correspondent to inner north conditions, the calibration of the and confirmation at light intensity was carried out using uranometer. The lab stimulated summer conditions. The Soria Spain was with maximum light intensity of up 1,700 micromole at noon. The 6x Luxeramide layer from 250 were used as photobioreactors for cultivation by microalgae. They were introduced without column. The total digest was ozonated and duplicated for the test. The digested remained in contact for ozone for 5 hours and chemical oxygen demand ammonia, nitrates, and phosphates. In addition, the oxidase was measured in the raw digest state. The absorbance between measured ultraviolet wavelength range of 200 to 400 nanometers and the visible range from 450 to 700 nanometers. The measure of the absorbance of the digest state in the spectrophotometer, a dilution of 1 to 100 was made. Previously, the spectrophotometer calculated the baseline using distilled water was from which it began to measure the absorbance of the samples. The percentage of color removal was calculated. The color removal. Microalgae grows quantities of 180 milliliters of treated and untreated digestate with dilution of 1 to 10 when incubated with 20 milliliters of algae inoculum, resulting in microalgae inoculum concentration of that final sample. During the test, absorbers at 550 and 680 were measured daily using spectrophotometer to monitor algae growth. To calculate the biomass growth of the microalgae in the culture medium, a correlation was made between the absorbance with the microalgae concentration of the culture medium. The concentration was determined by suspended rheology analysis while the absorbance was measured using a spectrophotometer test at wavelengths at 550 and 680. At different solid dilutions of algae and culture of 100 to 0%. Controlled and automated that were carried out in the duplicate. The data obtained on algae concentration were correlated with Helmholtz and Gawel's models. Solver control was used by means of the least square method. This is as follows. The specific growth rate and lambda is the delay phase. The adjustment of the key variables was conducted by means of the least square method and the solver tool of Microsoft maximizing the deviation experimental values. Oxygen production slopes were obtained at different points of distance from the light source, which corresponded to different light intensities. The experiment was performed according to the methods previously prescribed by Kostaj et al. A transparent flask of 10 milliliters was used to maximize the penetration of incident light into the culture. The self-oxygen was monitored by means of a probe, see figure S4. To maintain a constant temperature, the flask was ventilated to avoid cell death due to excess of temperature from the light cells. Constant oxygen was provided to the culture by means of magnet and steering plate. In this way, the microalgae were homogenized and received on the same radiation. When the concentration of the algae biomass in the culture medium spreads milligrams of dissolved oxygen per milligram microalgae per second. Color removal was by presence in wavelength by means of spectrophotometer was measured in the digest state. Chemical amount nitrites phosphates were measured according to the alpha standards. The digest state was ozonated to eliminate the turbidity and by the dark compounds by oxidizing them with ozones, thus reducing the coloration of the effluent. The mass flow coloration of the effluent, the mass flow consumption for 5 grams in 5 hours, responding to inlet and outlet 7 for 32, accounting for 30% depression. Reduction digested. The removal was limited to 23%, while removal reached a considerable higher value of 51%, evidencing that some of organic compounds present in the digestate don't attribute to the dark color. This is the case volatile acids, which account for more than half. In swine manual, the digester, according to the Rossi et al., significantly as higher removal have been documented by other researchers. For instance, detected chemical oxygen demand production higher than 70%. Oxygen dosage greater than 2 grams, considering of technical oxygen compound, chemical oxygen demand ratio of 1.5 to 1. The needed in our study was 0.30. These yields of removal efficiency should be then considered to scale up the treatment case. The average used processing of wastewater for oxidation is around $29 per square meter. The removal was evidenced by slightly biomass concentration reach up the test after 600 hours of incubation, treated and untreated digestate. However, of incubation while untreated assays needed more than 240 hours. These were in agreement with the previously reported experience. And with no treatment and with treatment of oxon was digestate was the microalgae growth was much higher because of 0.4 to 0.8, even 50% in after 4 times, but after 300 times, they was slightly big, only 20%. So the big growth was between 200 and 400 hours. So it depends. After some hour, the growth stops. Only also in ozonation. They related that in order to evaluate the impact of proposed concentration was availability. Light saturation, the right and photoinhibition. This point evaluated the transition zone from photolimitation to photosaturation were characterized by deviation consequence of the large impact of a small variation in the irradiance level. In previous research, there were similar values in terms of synthetic, but were lower than ozone. Ozone with zone gave dissolved oxygen with treatment was higher, giving more oxygen to the water. This is a good sign because is half the of oxygen in the places of cultivation, so the life could be done. Ozonation is essential for treatment inhibition of microalgae in digested soil manure. Colon was efficiently removed of even 51%. However, chemical treatment presented a high impact increased the rates of photosynthetic activity as oxidation success action resulting in a 4.4 times increase. According to the compass, the alga biomass took 19 days to grow. Less time to grow in the treated digestate than in untreated digest. That's all what I wanted to say. Thank you very much for listening to me.